Hello everybody, this is going to be my first actual video on this channel, and I'm starting this one out on a bang. This is going to be about a simple 4-bit computer that I've made by myself over the past few months, and I am very excited to show it off. It is called the dmud, and as you can see, it takes up 6 separate breadboards. It was made to just experiment with computers. Yeah, sir, it can't really do too much, though it was pretty interesting to work on. I'll talk through it. So basically, this computer, or, well, yeah, somewhat computer, was made just to tinker and mess with electronics, and also to help me understand how to use electronics a lot more better. As you can see, I have a diagram of the entire build right here. So I'll walk you through it. This part is the power supply, which takes in a barrel jack voltage of 9 volts and converts it into 5 volts to spread across breadboards. And then across here, is the clock section, where a 555 timer ticks with 2 separate modes, one being hooked up to a button and one being automatic with a variable resistor to change its speed. And there's a counter on here which counts up to the RAM, which basically cycles between 16 separate registers in total, outputting them here inside the RAM output. The thing that programs the RAM is here, called the programmer. I'm using the RAM so that I could clear it out when I turn it off. I don't really want to save the programs. It feels like it would be more fun to, reprogram it, well, walk through it. But right here is the programmer, which is like 8 separate dip switches with 2 other switches at the top. And out here is the output section, where for some instructions, it'll change 4 separate LEDs. It's very simple. Here's its instruction set, or more really, its basic outputs. At this 4-bit value, it will only change these 2 ones. Now, each one of these instructions are disconnected from one another. I didn't have the time to actually hook it up to a demultiplexer, so I just hooked them up to each separate chip. And I had to flip the bit count so that it could properly work, because most of them use like a negative signal to work. So this is what a blank piece of code would usually look like for me. So this 4-bit value is used for the output instruction and the jump instruction, while for these two, they're mainly used to just reset it. Now, I'll show you the board right here. And here it is. A second. It's a simple little onboard computer. As you can see, here's the RAM. Yes, I'm flexing off my RAM, along with the counter on the same breadboard as the clock, the button, along with the output section right here, along with the RAM outputs. Oh, where is it? I can't really fit on screen properly, but over here is the power supply with the power regulator over here, with a few capacitors to smooth out the signal. And here's the programmer over here. Now let me boot this on 1 second. I'm using this little barrel jack to power all of this. second, let me switch off the clock. It's already switched off. So currently, oh yeah, sure. I don't have any proper like power like regulation. But no, it's just for now. And also it was just for practice. So currently, the RAM is currently outputting this. And the outputs are currently outputting this. Just like these. The output and the clock use the same type of chip, specifically the 74LS163, which is a counter, which could also work as a 4-bit register, which is pretty useful. So let me try to make a simple program. Let's see. So this part, I am going to be using this switch right here to switch this quickly on and off to reset it. And as you can see, just like on the diagram, these 4 are on, while these 4 are off, because, well, on negative, it would be true for each chip. So let me make a simple program where we set this to 1 0 0 1, and then jump back from the beginning. So, a second. So let me flip this off and program it. 1 second. 1 0 0 and 1. So 1 0 0 right here inside the value section. And to set it to activate the output, it'll be this one. So here's the code currently, and let me save it. Let me turn off the switches. And as you can see, it did work. It saved. Here's the code. Wait, oh no, never mind. It didn't properly. Yeah, that's fixed. Let me flash it. Yeah, I'm pretty sure that's correct. Now let me tick forward. And then let me reprogram this to jump back to the beginning. Or no, it was on a high, so I would have to jump back to 16. And there. Here's what I put in, these parts right here. And then I'm going to save it. I'm not sure what's happening. A second. Alright, good news. I've troubleshooted a little, and I found the issue. And I was able to fix it. So, currently, the program... Well, alright. There's one small issue. This LED is not lining up, but I'll fix it later. So basically, this program will just loop through that. So, it'll start off with nothing, and currently the code says set it to 1 0 0 1, and to output that, which does somewhat work. I'm not sure why this one is not lining up. Though on this one, it just says the same thing again, because, well, I was still troubleshooting. Didn't skip through that. And this one, we'll just reset it back. Now, I do have a copy of this on Logisim, not the Evolution one, just the normal Logisim. If you want to like experiment with it. I also have like a few other things as well. Now see, I'm planning on upgrading this type of computer into a more better one called the dmud. What it was actually supposed to be called. Because I was trying to spell the reverse, like the reverse version of dumb, but then I ended up accidentally forgetting that dumb has B at the end. So this is going to be the more proper version, the dmud computer, with actual proper instructions and some more better space regulation, because on that one I was still trying to learn how to actually set it up. So I just mainly gave like each piece a lot of space. And guess what? I'm still working on it. I can show it to y'all right now. And I'm doing great on space. It can basically do what the dmud can with just a few extra wires. Currently these ones are not used yet, but yeah, it's basically just free breadboards with the power supply up here, with the RAM, with a power light, along with the clock and counter over here, with the RAM output and programmer on the same one, but this time with a lot of diodes, so that it could actually work a lot more better. I've made it so that it could also be compatible with this. So 1 second, let me turn on the on switch. And as you can see, each light does light up correctly. Just, it doesn't work yet. So currently it's just a set of blinking lights. Epilepsy warning, but this is how the clock can tick. As you can see. And with this variable resistor, so I turn it, speeds up. Point. Can't even tell if it's like, doing what it's doing. It's very fast. And let me slow it down. Down to the absolute. It also has a button as well, so that you can tick through it. Now, yeah, sure, I did wanted to use like another 555 timer, but no. I thought maybe I could try to debounce it, which somewhat works one way or the other. And yeah, along with that, we got the programming switch. This time with a program light, so that I could see it a bit more better. And a more easy, and it still works. Sorta. I'm still working on it. But yeah, that's it. I'm probably going to keep on working on the dmud, but that's all I have for now. Bye.